Good morning. I'm going to talk to you guys today about just reviewing the 812 factoring quadratics, which we had talked about before our break. So the idea is going to be that instead of starting with something and multiplying, so this is the product, and a lot of times we're given the product and we're asked to find what's the equivalent sum, we're going to be going the other way. But before we do that, let's just first start by trying to notice some patterns when we do the multiplication. We're going to use those when we try to find the things that we must have multiplied to get to a sum. So if I just asked you to multiply these with a box, let's start out like this. So what I want you guys to do is just take a minute, hit pause, and do this. Go ahead and multiply each of these pairs out and see what you get. And you want to write each product as the equivalent sum. And so go ahead and hit pause and then do that and then unpause and you can check your answer. Okay, so now that you've had a chance to multiply, let's see what we should have had. So we would have a 3x squared here, we'd have a 4x, we'd have a minus or a negative 9x, and here we'd have a negative 12. So for our sum, we would write 3x squared, and we would combine these together, minus 5x, and then minus 12. And then here we would have 10x squared, and then here we'd have negative 15x and negative 4x, and then here we would have 6. So for our sum, we would write 10x squared, we would combine these together and have minus 19x, and then plus 6. Alright, so now the idea is going to be, if I gave you the sum, so if I gave you these, for example, here are the sum, how could we write these as a product? Okay, so basically what are the factors, the things I'd have to multiply to get to the sum? So what we want to do is we want to notice some patterns from when we multiplied and use those for when we go to try to find the factors. So I'm going to start by drawing the box. And take a minute and look at what we did above when you did the multiplying and see if you could figure some things out about what the box is going to look like. So again, hit pause and take a look at what you had done when you did the multiplying and see if that gives you any clues about what you could fill into the box. Okay, so some things you might have noticed. Okay, those x squareds are going in that top left. So these x squareds are going to go in this top left box. Okay, so I know I'm going to have an x squared in this box. And this one I would have to have a 2x squared. Okay, what you might also notice is that this constant is in this bottom right box. Okay, so if I were setting these up, I know those would go in my bottom right box. Okay, so here I would have this positive 12 and here I would have this negative 6. Okay, so the idea is that everything in this box has to total up to be 7x, right? Everything in this box has to total up to be this, right? I have the x squared, I have the 12, so that means this diagonal here has to add to be 7x. This diagonal here has to add to be 1x, right? That's what happened here, right? These two added to be negative 5x. These two added to be negative 19x. All right, so I know that this diagonal has to add to equal 7x. Okay, this diagonal here has to add to be 1x. Now here's the thing, there's a million different infinitely high number of pairs that would add to be 7x, right? 1 in 6, 2 and 5, 3 and 4. I could have negatives, I could have decimals. Same idea here. So I need something else to kind of narrow it down so I don't have to just like guess and check. All right, remember last week we talked about Casey's pattern and how she had noticed that the diagonals in the box had to multiply to be the same thing. So we're going to use that to help narrow this down. So we need two things that multiply to be x squared times 12, or 12x squared. Over here, we need two things that multiply to be 2x squared times negative 6. This is negative 12x squared. But they're different because they have to add to be these different values. So think back to, okay, what's another time this year where we've had to think of pairs that multiply to be one thing and add to be another thing? And you might think, oh, those diamond patterns. Remember, they've been sneaking this in on us since the first chapter, right? So we're trying to think of combinations that in this case are going to multiply to be 12x squared and add to be 7x. And now over here we would be thinking of things that multiply to be negative, right? We said negative 12x squared and add to be 1x. So go ahead and pause and see what you can come up with. All right, so with this one, I'm trying to think of things that multiply to be 12x squared and add to be 7x. So you might be guessing and checking, like you might start with like 6x and 2x, and that works to get to 12x squared. But when I add them, I get 8x. That doesn't work. So then you're like, okay, what's another pair to get me to 12x squared? Like maybe 3x and 4x. Okay, if I add 3x plus 4x, I get 7x. All right, so then there's my pair for my diamond pattern. And I'm going to put that pair into my box. It does not matter if you put the 3x here and the 4x here or flip-flop them. 4x could be here, 3x could be there. All right, so the whole goal here is we wanted to know what had to go on the outside of the box so that when I multiply them together, it would give me this sum. Okay, so you could guess and check with it, but what's kind of easier is to like just pick a row or a column and look at this row and say, okay, well, what's a common factor between these two? I see, okay, they both have an x, so I'm going to put an x at the outside. Once I have that, I can really puzzle out the rest, right? So what times x is x squared? This would have to be an x. And then what times x is 3x? This would have to be a positive 3. And then x times what is 4x? This would have to be a positive 4. And if you did it right, then 3 times 4 is 12. So our factors are x plus 3 times x plus 4. All right, so this one, same idea, right? Things that multiply to be negative 12x squared, but now we want them to add to be 1. So you might have started with like a 6x and a 2x again. Now one of these would have to be negative, and that would get us the negative 12x squared. But let's see what happens if I add these. Here I get negative 4x. If I switched the signs and made the 6 positive and the 2 negative, I would get positive 4x, so that's not working for me. Okay, so then maybe I try the 4x and the 3x, make one of them negative, so maybe I start with a negative on the 4x. So I have negative 4x plus 3x, well that's negative 1x. I'm almost there. Let's see if I make it a positive 4x and a negative 3x, and I get, oh, there's the 1x I wanted. Okay, so this is 4x, and this is a negative 3x. Again, I'm just going to put them in my box. It, again, does not matter. You could have these flipped around. All right, then I'm going to look at, I usually just pick the top row, but it really doesn't matter. It could be any row or any column. Like I could pick this column if I wanted to and say, okay, what's in common between those two terms? And I could say, oh, 2 goes into both of them, and I could put a positive 2 up here. And then from there I could say, okay, well, what would this have to be to make the negative 6? This would have to be a negative 3. And then what would have to go up here to make this be negative 3x? Oh, I need an x. And then I have that, what would have to go here to get 2x squared? 2x. Okay, so then our factors are x plus 2 and 2x minus 3. Okay, so that's the big idea here. So I'm going to put 2 more up here for you to try. Okay, so again, you're going to start with your filling in your box. right? You know you can put the top left and the bottom right. And I'm going to kind of just write that down. So like our first step would be to put the squared term in the top left box and the constant, in other words just the plain number with no variable, in the bottom right box. So now once we've done that, we're going to make a diamond problem. Right, so with this diamond problem, it's that whatever goes on that second diagonal has to multiply to be the product of the diagonal you have, and it has to add to be whatever your x term is. Okay? Whatever these values are, these are going to go in the other diagonal of your box. Okay? Once you've done that, you're going to figure out what goes on the outside of your box. These are your factors. Okay, so figure out what goes on the outside of your box. These are your factors. So the idea should be, if you multiply your factors out, that you're going to get what you started with, right? You would get your sum. Okay, so take a minute, pause this video, try these two examples up here, and then unpause it, and then you can see the answers. Okay, so let's see. If I were setting this up, I would know for this one, the 3x squared goes in the top left, the negative 8 goes in the bottom right. I know that this other diagonal has to multiply to be whatever this is. So 3x squared times negative 8. So negative 24x squared. It has to add to be whatever that x term is, right? So I've got this in the box, I've got this in the box. These two have to add up to be that x term. So these have to add to be my x term, which is 10x. So I'm going to play around with different things that multiply to be negative 24x squared. So you might start with, like, I don't know, a 3 and an 8 and make one of them negative. But if you add those, it would be a negative 5x. So then I need another pair. So you might think of, I don't know, 4 and 6, 4x and 6x. Again, if I make one of those negative, I'm not going to get to 10x. You might think of 1 and 24. What about 12x and 2x? If I make the two negative and I add those, I would get 10x. So then that's my pair, 12x and negative 2x. Okay, so then those are going to go inside my box. I would look at these here and I say, oh, what's a common factor between 3 and 12, which would be 3. And I notice they both have an x, so 3x. And then I would have an x here, and 3x times this would be 4. This would be minus 2. Okay, that works. So I have x plus 4 and 3x minus 2. Alright, so then this last one, I would put the 4x here. I would put the 1 here. If I make my diamond pattern, I need two things that multiply to be whatever this product is. So that's 4x squared. And I need them to add to be whatever my x term is, which in this case is 4x. So I'm going to think of things that multiply to be 4x squared. So like I could try 4x and 1x. But if I add those, I get 5x, so that's not going to fly. What about 2x and 2x? If I add those, I get 4x, so there we go. That works. Those go in my diagonal. From here, let's say this time I decide to pull from this column. Again, it just really makes no difference. If I pull from a common factor from here, this would be like 2 goes into both of these, x goes into both of those. So then this would have to be a 2x. 2x times 2x is 4x squared. This would have to be a plus 1. Now this would be another plus 1. 1 times 1 is 1. So you have 2x plus 1 times 2x plus 1. Those are the same. We could get fancy and write 2x plus 1, that whole thing, squared. You don't necessarily have to, but you could. Okay, so as we are going through these next few weeks of not seeing each other, we'll be practicing this factor. It's going to come up in everything we do, so that when we get back, we're ready to go. All right, hope you're all taking care of yourself.